Good afternoon, ladies and gentlemen. To all of you, a warm welcome. My name is Uli Bobinger. I worked for several years as a space journalist in Germany, and I'm very happy to be your moderator for the next 90 minutes. First of all, I'd like to welcome the heads of space agencies and introduce them to you briefly. Ladies and gentlemen, please welcome from the host country of IAC2009, the president of the Korean Aerospace Research Institute, Mr. Joo-Jin Lee. From the United States, a man who has been in space 4 times, but for the first time, he's here with us as the new NASA administrator, Mr. Charles Bolden. Representing the European Space Agency, Mr. Jean-Jacques Dordain. The head of the Federal Space Agency of Russia, Mr. Anatoly Perminov. I'm happy to have all of you here, but especially Mr. Perminov, because he has a very tight time schedule and he has to leave us about 2:30, but I'm happy that then the deputy head, Mr. Saviliev, can replace him. So good that you're here with us. The director of the Indian Institute of Space Science and Technology, the brand new director, Mr. Madhavan Nair. The president of the Japanese Aerospace Exploration Agency, Mr. Keiji Tachikawa. And last but not least, the president of the Canadian Space Agency, Mr. Stephen MacLean. Ladies and gentlemen, our guests have a lot of interesting stories to tell. But to give you the chance to join in our discussion too, we agreed to start in the first round with very short key statements from the agency's heads on the status of development, ongoing cooperations, and on the plans for the next 52 weeks. We've scheduled only 4 up to maximum 5 minutes per person. And my job in this part will be to play sort of the bad cop and to give a sign to these honorable gentlemen when the 4 or 5 minutes are up. For this, I brought this nice bell from Glasgow last year. It's from a nice hotel in Glasgow. I really did buy that one, believe me. And if you start running out of time, I have to be unpolite and interrupt you with this. So let me apologize in advance, but we want to make sure that there's enough time for you to join in our discussion. In the second round, we'd like to discuss several topics of current interest here on the podium, and after that, you will get the chance to join in. At the entrance door, you probably got some sheets of paper for your questions. You can write them down whenever you like. We have 4 attendants in the hall. They collect your questions during our second round and take your topics then to us, to the podium. We won't be able to answer all your questions, unfortunately, but there will also be a website later on where the questions and answers also will be listed. So maybe can I ask my co-moderators and the attendants to raise their hands so everyone can see where they are and who they are. Thank you very much. So thank you very much for your attention. Now we start with our round of short statement, and we begin with our host from KARI, Mr. Joo-Jin Lee.
Thank you, Mr. Chairman. First of all, I'd like to express my sincere appreciation again for your all participants from 72 countries. So I think it's a largest Congress ever we done for this IAC. Then I think as a 60th anniversary, as I mentioned in my opening address, we have to make it whole the progress as the master of our activity so far we have done. So I think we make our IAF's role more enhancement with some sharing each task and also gathering our all each role to the federation. So that is my the first opinion. And then when you see our the program of the Korea, we have started our space program quite recently. Just our first program is now is started in the early of 1990s. Then only 16 years passed since the first space program in Korea, and then we launched our satellite, Earth-origin satellite, like a optical sensor. We call it COMSAT 1 and 2. COMSAT 2 is now under operation, and COMSAT 3 will be launched in the 2011, and COMSAT 5 will be launched in 2010. And also the meteorological satellite will be launched in 2010. So with those kind of satellites also, we will share to contribute of the monitoring with the satellite to the world, the monitoring of the environment. Then also, I think we have to extend our IF's role to educate young generation. So in order to make such a educational our task, we have to also make it some kind of a group. So in such a case, we can extend our IAF the activity to the some regional area. So this morning I suggested first, so if we have such a regional group, Asia Pacific first, and then we use that such a group for enhancement of the educational purpose to the young generation. So I think such a thing we can make our force together, our task together to make a sustainable and then a progress for our humankind of the world. So that is my the brief opinion for this at Congress. Okay, thank you.
Thank you very much indeed, Mr. Lee, and I would like to hand over to NASA and to Mr. Charles Bolden.
Thank you very much. Aha, thanks very much. It's a pleasure for me to be here. This is actually my first conference, and I'm just old enough to have made all of them had I started. But it's a pleasure for me to be here. I'd like to just give you a very quick summary of where we have come over the last year since the last conference. As most of you know, the United States has a new president, Barack Obama. NASA has a new administrator, me, and a new deputy administrator, Ms. Lori Garver. And we're very busy doing some of the work that is follow-on to what my predecessor did. We continue to be very active trying to build strong international partnerships as we have done over the last 50 years or so. We have some of the highlights. We actually launched STS-125, which was the final Hubble Space Telescope servicing mission. Incredibly successful. We did 5 EVAs on 5 consecutive days, which had never been done before, and left Hubble with in the condition where it now has 5 functioning instruments simultaneously. We also launched STS-127 and 128. 127 was very special because it enabled the International Space Station to truly become a mini United Nations. For a period of time, we had 13 astronauts representing all of the member nations of the International Space Station Consortium on board. On STS-128, we like to say we had an American astronaut using a Canadian arm, lifting a Japanese satellite and docking it to an International Space Station. So that was a highlight for us. Just this past week, we saw the culmination of the Lunar Reconnaissance Orbiter and LCROSS mission where LCROSS, the satellite itself, and its lunar orbiting rocket engine actually were plummeted into the lunar surface. The initial indications from the preliminary data we have is that this was very successful, but it'll be several weeks before we have final data out. We continued construction of the International Space Station. 3 missions in 2009, completed the assembly of the Japanese equipment module, Kibo. We have increased the crew from 3 to 6, fully functioning, and delivered the final sets of solar arrays. During this period of time, we actually demoed proximity operations of both the ATV from the European Space Agency and HTV from the Japanese Space Agency, or JAXA, and then birthed both of them to the International Space Station. We have a robust program of coordination with our FAA, or Federal Aviation Administration, on what we call NextGen, which is the next generation air transport system, trying to improve aviation for all of us around the world, whether it's throughput in airports or efficient travel once you get airborne. Probably the thing that all of you want to know about is the Augustine Committee. They have completed their work. They had one final public session last Thursday, and we expect their final report to be issued any day now. This will give us help in determining the future course of human spaceflight in America. Dr. John Holdren, the President's Science Advisor, and I will sit with others with the President and make recommendation to him on what the course of human spaceflight for the United States will be, and that will affect all of us. And finally, I'd like to say I'm very optimistic about NASA's future. I've had an opportunity to interact with all my international partners so far, if only now everybody here, but before that by phone on my first 2 days. And we have robust partnerships, and we look forward to doing lots of things with all of you that pay attention to the climate, to our kids in terms of education, and many more projects. Thank you.
Thank you very much, Mr. Bolden. Many activities you mentioned, especially the space station and space station now, since some days has an ESA commander for the first time, Frank de Winne. So I would like to pass over to head of ESA, Mr. Dordain.
Okay, thank you very much. Just to recall that myself, I am representing 18 countries of Europe, a member of ESA. Since the last meeting in Glasgow, there was a very important event, starting by the Council at ministerial level, which took place in November last year. And that Council of Member States took a very important decision for the future of ESA, with a reinforcement of programs related to science, with an increase of the budget of the science program, with a very big program to use the space station, and starting a new initiative on climate change. That this is for science. The member states, they have also decided a lot of new applications program for the citizens. The third generation of the meteorological satellite that we shall develop together with EUMETSAT. The new slice of the GMES, which is services associated to environment and security, which is under the European Commission, but we are making the development of the first satellites of GMES, and also a new program related to integrated applications. And the Council has also opened new avenues with the robotic exploration of Mars, with the ExoMars mission, but also with preliminary studies on a cargo return vehicle, and also of a moon lander. Having said that, we had also very important missions since last year, starting with the launch of Goche, which is the first of the Earth Explorer missions. Just to say that in one calendar year, we shall launch 3 satellites dedicated to Earth science and its environment, with Goche, the first one in March this year, with SMOS, the second one, which will be launched on the 2nd of November, which will look at the water cycle in the atmosphere, and the third one, Cryosat-2, which will be launched in February next year. We have launched also, and it was recalled this morning by the President of the Federation, we have launched two fantastic observatories, Herschel and Planck, which are two observatories which are now at the second Lagrangian point and which are looking at the origin of the universe. Also, and it was related by our animator, we had astronauts on board the space station with Christophe Fuglesang, who made two EVAs, but also with Frank de Winne, who is now the commander of the space station. And I am glad that Frank could become the commander of the space station on the 12th of October, because this is Columbus Day. And for ESA, Columbus is very close to our heart. We shall launch also next year. We shall have the launch of Soyuz from the French Guiana, of Vega, and also in November of the ATV-2 Johannes Kepler to the International Space Station. As you can see, it's a very busy year, full of international cooperation, because most of these programs, if not all, are in cooperation with the partners which are sitting today on the podium, but also other partners in the room. Thank you.
Thank you very much, Mr. Dordain. Pass the floor to Mr. Perminov.
Okay, thank you very much. Roscosmos также решал ряд задач, и основные усилия в этом году были направлены на сохранение высокой интенсивности запусков, прежде всего.
Roscosmos was answering different very important issues, and one of them was to maintain a high rate of launches.
За этот год уже произведено 23 запуска, что составляет 40% от всего количества запусков по всему миру.
This year we have performed about 23 launches, or about nearly 40% of worldwide space launches.
Правительство увеличило финансирование по целому ряду научных программ, и прежде всего в системе развития связи. Были запущены два космических аппарата, Экспресс-М-44 и Экспресс-МД, в геостационарную орбитальную группировку.
Our government have taken decision to increase financement of several programs, especially in the area of scientific and applied use. For example, we are increasing the capabilities of our telecommunications satellites. For example, this year we have launched the Express AM44 satellite and Express MD1 satellite, both of them on geostationary orbit.
В сфере науки на орбиту был выведен космический аппарат «Коронас-Фотон» для исследования физики Солнца и солнечно-земных связей, успешно работает.
In the area of scientific studies, we have launched the Coronas Photon scientific spacecraft, which is dedicated to the studies of solar physics and solar terrestrial links.
Excuse me, Mr. Interpreter, please just take the mic a little bit more to your mouth.
Другой научный аппарат Phobos-Grunt, к сожалению, будет перенесен на более удобное окно на 2011 год, астрономическое окно.
Other scientific spacecraft, Phobos-Grunt, was unfortunately delayed to other more convenient astronomic window in the year 2011.
Мы приступили к восстановлению и модернизации группировки метеорологических космических аппаратов, и запущен новый современный метеоспутник «Метеор-М».
we have started to rebuild our national constellation of meteorological satellites. For example, we have launched a totally new Meteor-M satellite, and it's fully operational now.
Активное внимание уделяется развитию навигационной системы ГЛОНАСС.
We're also giving great attention to the enhancement of satellite navigation system called GLONASS.
К концу года мы планируем запустить еще 6 космических аппаратов, чтобы система работала по всему миру.
We plan to launch 6 new satellites by the end of this year in order to ensure global coverage of GLONASS system signal.
Что касается международного сотрудничества, в основу, конечно, у нас лежит это работы по программе Международной космической станции, и мы ее выполняем.
As for international cooperation, our main activity in this area is ISS, and I would like to stress the fact that they are completing our engagements on full scale.
Экипаж станции увеличен до 6 человек, и до конца года мы должны запустить исследовательский модуль МИМ-2.
So the crew of the international station increased to 6 people, and we plan to launch by end of this year a new small scientific module called MIM-2.
Я надеюсь, как сказал господин Dordain, мы выполним все обязательства по Союзу в Гвианском космическом центре.
And as Mr. Dordain already said so, I hope we will complete our works on Soyuz in Guyana project.
Ну и осуществлен первый запуск в рамках совместного проекта по запуску корейских космических аппаратов.
We have already also performed the first launch in the framework of Korean Space Launch System program.
Спасибо.
Thank you very much.
Thank you very much, Mr. Perminov. Now, Mr. Madhavan Nair, I have to apologize. I think I didn't introduce him correctly. I'm sorry. For sure, so you know, Dr. Nair is chairman of the Indian Space Research Organization, ISRO. I'm sorry. Now the floor is yours, Dr. Nair. Dr. Nair, where?
Thank you very much. First of all, let me express my gratitude to IAF for giving me this opportunity. First slide, please. Indian space program is well defined and based on the societal needs, and we have well established launch systems like PSLV and GSLV, and also the Earth observation series of satellites called IRS, and communication series satellites in geostationary orbit, the INSAT. We had 54 missions carried out so far. Out of them, 29 have been from using the Indian launchers from the Indian soil. The self-reliance in the space transportation, spacecraft preparation and operation, and maintaining leadership in some of the application are the primary goals. Our budget is fully supported by the government, and we have roughly about 20% increase in our budget over the last year. This shows the commitment of the government towards the space program. Of course, I would like to touch upon one of the major achievements we had in the last 1 year, that is the mission to moon, the Chandrayaan-1. Here, we have sent a spacecraft to moon and placed it in a precise orbit around the moon with very close accuracies, and it carried about 11 instruments on board, 5 of them coming from international community, from USA, Europe, and Indian scientists also participating in this. And one of the path-breaking discoveries of this mission was a combined objective between NASA and ISRO, that is finding traces of water on the surface of the moon. Well, of course, the Chandrayaan has survived for about 300 days around the moon, and it has given a large volume of data on the terrain features, the hyperspectral imaging on the surface, and also the many of the inputs which are being looked for identifying the mineralogical content on the surface of the moon. So this has been a very highly acclaimed project. Of course, also we had opportunity to carry a radar satellite for imaging purposes, and also the Ocean Sat, which has been launched a few weeks back, is meant for studying the ocean color and very good input for the fishermen to identify the fish school. And also the scatterometer, which provides the wind profile on the surface of the ocean. We have also incorporated with the Italian Space Agency a radio occultation receiver using the GPS, which will give the atmospheric profile of the temperature and a wind. Next one, please. Our space program has been based on the inputs of the common man, and it is addressing various issues related to healthcare, education, empowerment, contributing towards the food security and the natural resource management. The inventory which is created using the space-based images is widely used for the planning purposes, and it has become a very powerful tool. I would like to highlight that the telemedicine project, what we have implemented, is one of the unique systems by which the remote villages are connected to the metros, where the specialist hospitals are there, and through the transmission of the data over the satellite of the patient and having a teleconference, the healthcare is taken to the doorstep of the villagers. The education system also has been supplemented quite a lot by having the teleconnectivity, and this provides expert classrooms to be available to the remote schools in the villages and far-flung places in the country. We have evolved a system of what's called a village resource center, which integrates the space images, the education and the healthcare system, and the village resource center addresses and provides a single window provision for making use of the satellite-based services for the rural community. Next one, please. The Indian space program is based on a long-term vision. We have cast the vision for the next generation going up to 2025. As part of this, we have the objective of developing a powerful launch system which can nearly double the launch capacity compared to the existing launch vehicles. Also, we have demonstrated the payload recovery, that is the spacecraft recovery from the space, and which will lead to the inputs for the human spaceflight program, which has been just initiated. And we hope that by proper funding and efforts by 2015, we should be able to have our own manned mission around the Earth. Also, we believe that cost of access to space has to be brought down. Towards this, recoverable and reusable launch vehicle technologies are being targeted. We have the program for demonstrator which will wet our hands on hypersonic flight of vehicle system, and which ultimately could lead to a two-stage to orbit by about 2020, and maybe by 2050 a single stage to orbit, and so on. Well, our efforts are primarily to provide the Earth observation for the natural resource management, the climatological studies, the weather studies, and so on. And this will be strengthened by having the hyperspectral imagers and the radar imaging system which is coming in. The communication system will further grow into providing point-to-point communication with high bandwidth, and also the personal communication from the satellite-based system. The satellite navigation system, which is called the Indian Regional Navigation System, is being evolved, and by 2012 it may be operational. We have international cooperation with France and Germany, USA, Russia, and so on. As part of this, we are going to have a Megatropics, a satellite launch to study the tropical climate and weather phenomena, and this is later for launch in the early next year. This CNES and ISRO is working together on this project, and also there is a project to have the altimeters flown on the Indian satellite from the French side. With Russia, we are very closely working on new systems and GLONASS application, and also the possibility on the human spaceflight system. And with NASA also we have close links. The Chandrayaan-2, which will be follow-on of the Chandrayaan-1, will carry instruments not only from India but from international community as well. We are targeting to have the Earth-based observation system and other application system. At the same time, we are trying to have part of our research focused on knowledge acquisition, that is towards the planetary exploration within the solar system and so on. So this is a driving force before the Indian program, and we have a budget of roughly $1 billion per year at the moment, and a strong workforce, nearly 16,000 people directly with ISRO, and equal number of people working from industries and academics in India for the space program. Thank you.
Thank you very much, Dr. Nair. Now I'm looking forward to hear the statement from Mr. Tachikawa.
Thank you. More light, please.
Can we have a little bit more light, please? Where's the Capcom? Thank you.
Okay. Thank you, Chairman. I would like to introduce the summary of the last year activities. In this January, we launched Ibuki Greenhouse Gases Observing Satellite from Tanegashima Space Center in Japan. As you may already know, Kyoto Protocol was adopted in the third conference of the parties to the UN Framework Convention on Climate Change, COP3, in Kyoto 1997. And later, it has become effective in February 2005. From this effect, the cut of the emission of greenhouse effect gas, such as CO2, has been obligated. On the other hand, in 1990, the importance of the system structure of environmental observation has been proposed by the GCOS, Global Climate Observation System, in WMO, World Meteorological Organization, and UNEP, UN Environmental Program. To contribute to this proposal, Ibuki has been surveying the density distribution of CO2 and methane every day from space. The picture of the back screen is one of the observation result of carbon dioxide regional density distribution, which Ibuki has been acquired until now. The environment issue is a major problem of the world, and it is a highly important matter which all human beings should challenge. To utilize the observation data of Ibuki to solve this problem, we are planning to distribute the data of Ibuki to the scientists and researchers in the world. We are expecting eager result in near future. There will be a report of the research result from the scientists and researchers all over the world using Ibuki data, and it will help the solution of environment issue. Next, I would like to talk about Kibo in International Space Station. Japanese experiment module. We finished all the construction in July. Kibo had been launched 3 times by the space shuttle since last March by the help from the international partners. We appreciate very much your support. The completion of Kibo is a big progress for Japanese space development in respect of settling the test site of microgravity on the orbit. Kibo is planned to be used mutually by the international partners which participated in the plan of Space Center in the range of each utility right. Japan is now doing many experiments on medicine science and engineering using Kibo, and also planning to continue the research by adding the public experiment. Also in this September, Japan launched the HTV, the H2 transfer vehicle, which conveys the materials and experimental equipment to the ISS by the new type rocket, the H-2B, from Tanegashima Space Center. The H-2B succeeded in docking to the ISS using Canadian arm of the CSA and also done by the help from a commander of FSA, Russia, and operator of ESA. It is beneficial not only for Japan, but also for the countries which participate to acquire the way to transport goods to the ISS. As I have introduced now, I am very much in confidence that we have achieved many results in the last 1 year. We are in deep determination that we will continuously focus our efforts to the activities for all human beings under the cooperation with international partners. Thank you.
Thank you very much indeed, Mr. Tachikawa, and we already saw some Canadian space activities in your presentation. So, Mr. MacLean, now it's yours.
Yeah, it's great to see. Canada needs to cooperate internationally, so I just listened to the previous speakers and I see a little bit of what we do in every country. It's a pleasure for me to be here. This is my first time, just like Charlie Bolden, it's my first time in the Republic of Korea. I have seen it from space. It's pretty from up there, and being on the ground, it's just as pretty down here. For Canada, it's been an interesting year. The Canadian Space Agency, even though we launched our first satellite in 1961, we are formally an agency for 20 years now. We're celebrating our 20th year. It's also our 25th anniversary of human spaceflight. Marc Garneau flew October 5th, 1984, and we have had 15 flights since that time. 2 of those space flights were this year. It's the first time Canada has had 2 astronauts in space at the same time. So from a human spaceflight perspective, it's very interesting for us. We had STS-127 with Julie Payette and Robert Thirsk, who launched from Kazakhstan in late August. I think he's on his 137th day today, and he'll be landing December 1st. We also had a bonus flight, I think, with Guy Laliberté, who just landed late last night near Kazakhstan. And if you haven't seen the 2-hour special that he did the other night, I think it's well worth watching because it raises a different level of awareness for what we did. And I was very appreciative of his last 5 minutes where he spent some time describing his appreciation for all the space agencies. Couple bureaucratic things that we got done this year. Charlie Bolden and I signed the Canada-US Space Treaty Agreement in September. I think for Canada that's more important than it is for Charlie Bolden. What it does is it brings the level of authority down for joint missions between NASA and CSA to the level of the president of CSA and the administrator of NASA. And for us, that gives us the opportunity to react to international opportunity much more efficiently. This year is also 30 years of ESA cooperation, which is something that Canada is very proud to be an associate member of ESA, and we are in the process of renewing the agreement for this December. The main work that I've been doing over the last little while is our long-term space plan. Given that we're at a crossroads with respect to the space station assembly being complete, some of our larger satellites have been launched and are there. We're looking at what we're doing next. So I have a mandate from the Government of Canada to come back with a vibrant national space program. We are doing exactly that. I have finished the consultation. There are 14 government departments involved with space in Canada. It's the Canadian Space Agency's mandate to coordinate all that. So our budget is a lot larger than just the CSA's budget. And also, there are 23 universities that the CSA works with. And when we work with the university, our leverage is 1 to 4. For every dollar that I invest, we basically get $5 worth of activity. And I'll talk a little bit about that in a minute. So out of this long-term space plan, it's very similar to what our partners have here in the sense that a portion of our mandate is to serve public priority. And so we do that in the face of what the government priorities are for Canada. And in our case, it's sovereignty, safety, security, healthcare, global climate change, natural resource management, and there's a few others. The second main activity that the long-term space plan espouses, and I should comment that we are at the political level with this plan now, and so it's a matter of pushing it through Parliament and hopefully with success. The second pillar is to be a valued partner with respect to space exploration. This is something that is very important to Canada. We have a good flight heritage there with the International Space Station. We hope to continue that. And the third area is an area where we hope to build capacity to be ready for larger budgets in the future. So I guess that's an optimistic way of looking at it. We want to align the work in the universities, align the work in the 14 government departments into, if not one entity, but one coordinated effort. And so we're working on that. And in building that capacity, the whole idea is to enhance our ability to react to international opportunities since we don't launch ourselves. So we're working very hard on that. We did receive money, extra money, in the last budget, the stimulus budget. We got $110 million to basically design and develop terrestrial equivalents of space robotic vehicles. And so the companies in Canada that are involved in that are very excited with that budget increase. If I spend just a little bit of time on a couple of projects that we're going to focus on, given our position in the north, we plan to put more ground stations up in the north, and each of these, there'll be 2 in the north. Each station will be a multi-antenna farm. I encourage, Germany has already has one antenna that they own that's in the north. I encourage any other country that wants to participate with this to do that. We are working on a data policy. You could spend an hour just talking about data policy in a conference like this. It's domestically, it's Canada's opinion that data should be more free and more available so that the application world, that's where the value added is. That's what we would like to do. And so we are encouraging that and hoping that internationally that will be a major player as well. Our 2 major projects in the long-term space plan are the RadarSat constellation, which is a series of 3 satellites, similar to RadarSat 2, but lighter, and they will give us a more operational environment with respect to our work there. And the second main project that we're in a phase 0, phase A type study at the present time is PolarSat. So this is a constellation of 2 satellites that will have weather, communications, and also probably a global pollution monitoring experiment on it. So for the next year, given that we're at a crossroads, what we're trying to do is get the approval and implementation of this plan. And that actually comes with a request for more money. We will be focusing, it's my wish that when I come back here next year, I can tell you that that plan has been accepted, that we have spent more money on developing a small satellite program. I think that's the way of the future, so we're working very hard to develop a series of instruments that can go on small satellites that meet our government needs. And it is my final wish that next year that we as a group have progressed much further on global exploration. I would like to see progress in that area. So thank you very much.
Thank you very much, Mr. MacLean, for your interesting remarks, especially for the remarks about the budget. It's interesting that even in times of economic crisis, budget problems can be solved when the public opinions grows, that space can be a solution also for the problems we have. Thank you very much. Now let's focus on some of the key topics you gentlemen already mentioned and that will be coming up in the Congress also. At 3 p.m., 19 technical sessions will begin. Let's take one of them.
Excuse me, Mr. Chairman. Let me have a chance to introduce my Korean space program. I couldn't make it.
I'm sorry.
Sorry. So yeah, at the beginning, just I made the introduction first, say hello, and then now let me have my chance to introduce our Korean space program for your understanding. worldwide. Okay, please, my biography. Okay, next page. Next page. So in our Korea, we have a mid and long-term space development plan. As you see, in the middle of that, you see the 2009 and 2010. We launch the first launching vehicle program with our satellite is a STSat-2, and then you see that next year again COMS, that is a communication, ocean, and meteorological. And then if you see that in the same year, the named COMSAT-5 is a radar satellite with a radar image, and it has several the resolution. I will explain a little bit later. And 2011, also COMSAT-3. So you see that all the program is condensed in next 2 and 3 years. So it's kind of a such a all the progressive, but the fruits come through in the next 2 years. So this is all my responsibility, and also that is a kind of something incidental, a condensation. So if you see the continuation of the program, you see that COMSAT series, that is a Earth observation satellite. Then you see the series of the COMS, that is a meteorological, so that is a geostationary. So if you go look on the bottom, 2016, that is another geostationary with a mission of a meteorological. Then we also made a plan to send at the lunar orbiter in 2020 and lunar lander in 2025, but with some kind of a robot inside. Okay, next page. So that is we categorized in 3 fields. First one is we call launching vehicle. Second one is Earth observation satellite. And then third one, we also developed the scientific satellite for the educational purpose. Then it didn't written in this biography, and we also developed that meteorological satellite. So we had actually 4 categorization. Next page. And then the recent the program, ongoing program I call, is for the COMS. That is you see that we have 3 sensors, and then it's for the ocean monitoring. It has a 500-meter resolution, and for the meteorological and also communication payload it has. So this satellite will contribute for that monitoring of the Earth environment, and also I call the accurate monitoring of the ocean color. So it will be very useful for the next several years. Not yet. Okay, continuation. And for the COMSAT-3, it has very we call high resolution optical camera there. So with this one also we can make a precise observation of some kind of the contamination or the pollution. And COMSAT-5, it says also radar with a high resolution 1 meter, and then medium resolution 3 meter, and then lower resolution is 20 meters. So it will be very feasible for observing the reflection of each object. Okay, next one. So it's one example for the COMSAT-2. The COMSAT-2 is now on the operation with a resolution of 1 meter. Then the swath is a 16 kilometer. So we utilize that data as you see it in the first picture, as the land cover, and then also for monitoring of a kind of the pollution of the water. Then also we use as a cartography. Okay, and next one. Okay, so it's one example of the cartography of our Seoul. Yeah. Continue, please. Okay, so this is a one example of the resolution. And next one. Next page. And also this, you know quite well about our first astronaut in last year. You see her this morning at the our opening ceremony. Next one. And you know quite well about our LV1. Okay, next one. Okay, so we also have our several ground stations for to control the satellite and also tracking the launching vehicle. Next one. And also we have our plan to join this your lunar network with several countries together. So we will continue those kind of our contribution to the space investigation and also the monitoring of the Earth environment. Okay, thank you again. Thanks.
Thank you very much. Thank you very much, Mr. Lee. Mr. Perminov is going to leave. We're sorry. We wish you a good flight and hope to see you next year in Prague. Goodbye, Mr. Perminov. And if Mr. Saviliev is around, he's welcome to join us on the podium. And I would like to focus on a topic all of you mentioned in your first statements. So please give a hand to Mr. Saviliev. Welcome in our round. Just take a seat. Well, we're waiting for the UN Climate Conference in Copenhagen end of this year. And what kind of activities you think space agencies can deliver in this field of Earth observation and tackling climate change? We heard something about it. Mr. Dordain, ESA, as we all know, has launched a climate change initiative. What will be the concrete steps in this field for the next year?
Okay, thank you very much. I would like just to start by saying that space will not provide the solution to climate change. Climate change is a very complex issue which requires a long chain of actions from collecting data to understanding to predicting, acting and monitoring. And these long chain of actions must be done consistently. And space is not part of all these actions, but clearly space is at the start, collecting data, and at the end, which is monitoring. And this is where space is very important. So as you said, the member states of ESA, they have put, I would say, priority number one in everything concerning environment and climate change. We have three different parts of programs. One which is dedicated to science, which is collecting data for better understanding, and that this is the Earth Science program, but also I would say the Space Science program, because learning something on Mars or on Venus can be also important for the Earth. But there is all the activities related to improving the knowledge. The second part is taking the improvement of the knowledge to provide services. This is the operational part, and this is what we call the GMES, which is Global Monitoring for Environment and Security. And you are right, at the last council at ministerial level, the member states, they have decided to open a new line in this overall activities related to environment and climate change, which is a climate change initiative. Because so climate change initiative is just to transform data into information. Because the satellites, they are just providing data, which is temperature, winds, species, and so on. And the problem is to transform this data into information, and this is the essential climate variables which have been defined in the Bali conference. And the member states have taken the initiative to make another step towards the understanding by storing the data that we are collecting, but also transforming those data into information and variables which can be directly used by the scientist. So as you can see, it's a lot of efforts which is done by ESA, but in full cooperation with our partners on that environment and climate change. We have cooperation with Canada because Canada is part of the ESA programs related to that, but we have also cooperation with JAXA, and especially on one important mission, which is EarthCare. The first time that I met Charlie Bolden, the first topic on the agenda was not the space station, was not exploration, but was environment and climate change. So we are working with a lot of, and by the way, tomorrow I have a meeting with Monsieur Nair to talk about that. So to say that this is a cooperation endeavor. Let's say the big issue for me, there are two big issues there. It's number one, to have a data policy, because this is clear that we are all collecting data, and the key point is to make sure that we have a coherent data policy. It's number one. And number two, to have a coherence in the efforts of this chain of actions, because we shall deliver more and more data. What I would like to be sure is that downstream of what we are doing, there is all the efforts and all the resources which are there to use those data. So this is how I see the picture of climate change.
Thank you very much. I suppose the matter of data policy, data-free policy will be one of the most important topics in this field. Mr. MacLean also mentioned that.
Yeah, I would just like to add to what Jean-Jacques Dordain said, because there is an expression, data, data, data. And what I can't agree more with the comments that were just made. It is accurate data, it's long-term data, and it's data that has the same geo-reference, if you like. One of the things that's very important, if you want to get at the trace elements that are going to help you improve your climate models, you have to get that information at the different layers as you move down through the atmosphere. One of the issues that we have, and I know that because this is true in Canada, it takes practically a master's thesis sometimes to compare upper atmospheric data to data that's down in the lower atmosphere. So there needs to be some improvements there. One of the aspects that I think is important that we're going to try to do in Canada is to collect data that will do two things, that will improve the climate models that are out there, and therefore it's very important to understand what the weaknesses are in those models, so that we can improve the models. And then the other thing is to make sure that you have all of this data that you can give to the leadership of the nation so that you can reduce the disaster scenarios, if you like. You need to have accurate data so that you get what is really going on. And I have to be careful when I say this, but I would really like to see the number of people who don't know much about climate change. I would like to reduce the number of talking heads that are on TV and get more of the people that work in this area on TV talking about climate change. That's something that I consider very important. So it's the improvement of the models, which is part of the chain that Jean-Jacques was talking about, that will turn climate change into an opportunity, and an opportunity that we all can react to.
Thank you, and I think there were many hopes this year to get some new, fresh data, Mr. Bolden. You told us about many successful things this year, but some hopes were destroyed with the OCO satellite. Then you had to face a failure. So what are your initiatives for the upcoming 12 months in this field of Earth observation?
The United States, like I think all of our nations represented here, have come to the conclusion that climate change is most important to all of us. I think back to 1992 when I flew the first flight that I had an opportunity to command. It was called Atlas I. And on that mission, we actually had 10 experiments, 10 international experiments that looked into our atmosphere, into what we call the middle atmosphere or the mesosphere. At that time, it was affectionately called the ignorosphere because we knew nothing about it. Today, we know much more. I think back on Apollo 8 when we saw the famous Earthrise photo, and the Apollo astronauts then said we had to leave our own planet Earth to learn that we needed to know more about ourselves and our environment. So NASA is dedicated to flying more missions that will increase our understanding of climate change. We'll continue to get Earth observations from space because, as Steve said, they will play a major role in helping us to understand global climate change. I'll echo something. I think Steve talked about the strategic plan for climate change that is an international effort. In the United States, we actually have a strategic plan for U.S. climate change science program. I reflect on the conversation that we had last night after the day-long meeting of international parliamentarians when they focused on the environment. I commented that, one of the things you observe when you go to space is that we live in one ocean and we live in one atmosphere. And we need to help people understand that. We need to educate the public in our respective countries so that we can have informed debate about climate change. Steve refers to the talking heads. They make money talking about nothing sometimes. And I think it is our duty as a scientific group to make sure that our own public understands a lot more about the environment and the climate so that we can conduct intelligent discussions.
Thank you very much, Mr. Bolden. Mr. Tachikawa, I think nearly 50% of the population of Japan lives near to the coast, so climate change and global warming with its threats must be a challenge for you also. Your Prime Minister made a commitment to reduce CO2 emission about 25% up to 2020. What services JAXA is able to deliver that?
Thank you. Thank you. First of all, I would like to talk about how to compete with climate change. Number one, we need more data from observation satellite. Secondly, we have to analyze them. And finally, we should make action how to do to cope with the climate change. So JAXA in Japan, we would like to promote more data from the satellite. So we are now spending a lot of money to develop a new satellite, such as, say, Daejeon is already in the sky, but we are now developing a GCOM series, Global Change Observation Mission. This is just water cycle and climate changes are targeted to be observed. And GCOM W will be launched in around 2011, and climate change will be around 2014, respectively. Another one, we are now working with NASA about GPM, DPR. This is a global precipitation mission. So this will be launched in 2013. This mission is to observe the rainfall over the world in detail and grasp the change of water cycle. Also, by observing the precipitation and the change of its areas, it contributes to resolve the abnormal weather. Another one is Earthcare. We are working with ESA. This will be launched in near future, I hope. It will be launched by ESA. So JAXA is now preparing a portion of a satellite about observing cloud and aerosol in the sky. So anyway, we are developing many such kinds of satellites. So next, we must ask scientists or researchers to make a good analyze them. And after that, we set up a new strategy how to compete with the climate change. Thank you.
Thank you very much, Mr. Tachikawa. There were many more things which could be discussed in this field of climate change and earth science. But now I got your question. Thank you very much for writing down so many questions, and many of those questions are focused on the other field. Also, I would like to stress during our podium here, it's focused on manned spaceflight and space exploration. And maybe you allow me to start just with your questions. Thank you again for that. Well, we have a question here which goes to Dr. Nair from ISRO. Do you see a role of ISS in your program, Dr. Nair? And do you plan to join the human spaceflight programs at an international level? Thank you for this question.
Well, at the moment, we are not part of the ISS team. We would like to very much join that if possible. But at the same time, we believe that human access to space is an important capability. And being one of the largest populated nation in the world, we would like to have that capability built in India. So we are nucleating a program by which we will have a capsule which can carry something like 3 passengers to space and back using one of our indigenous launchers. So with this, by about 2015, we hope to establish our own capability to access to space. In the meantime, we have developed what is called a spacecraft recovery experiment, in which something like a 500 kilogram spacecraft with capability of carrying a 50 kilogram module for material processing on board or any other experiment which needed. And this can be safely, the sample can be returned to ground. The first of its kind, the experiment has done 2 years back, and next year again we will have the repeat of that. It's going to provide an opportunity for the international scientific community for providing low-cost experimentation under micro-G conditions. Of course, we had a brief chat with Mr. Bolden last time when we met. He has suggested that when Indian capsule is being made, the interfaces can be defined in such a way that it could be interchangeably used for many of the missions.
Thank you very much. I think climate change has been a good example that international cooperation will be a must. At the space station, it's a very nice example that international cooperation did function up to now very well. Now, as we are in the field of the ISS, Mr. Savilyev, what do you think, what will the next years bring, especially in the field, I have to ask Mr. Bolden later on also, in the field of launch vehicles, because from 2011 maybe it's used to launch the flights to ISS, maybe not, I will ask Mr. Bolden later. Did you get it?
Значит, что касается взглядов Роскосмоса на текущие перспективные средства выведения.
In what refers to the point of view of Roscosmos to launch vehicles?
С точки зрения Федерального космического агентства России, с учетом текущей ситуации в области запусков, а также перспектив расширения грузопотока на орбиту, ввиду реализации масштабных программ исследования ближайших планет Солнечной системы, перед космическим сообществом стоят две основные задачи.
Well, with the increase in the possible and prognosed increase in the loads transported to the orbit due to realization of extensive programs of interplanetary flights, planetary exploration, and possible extension of human presence on the in the space, we think that most spacefaring countries have two issues in what refers to the launch vehicles.
Первое заключается в совершенствовании существующих ракет-носителей для сокращения затрат на выполнение существующих программ запусков космических аппаратов.
First of all, first task is to modernize existing launch vehicles in order to reduce cost for their exploitation and to improve them.
И вторая задача заключается в создании на новой технологической основе экономичных и высоконадежных средств выведения тяжелого и сверхтяжелого класса.
And other thing is to develop new, highly efficient and cheap transportation vehicles of heavy and super heavy class.
Роскосмос решает эти задачи следующим образом.
And for example, Roscosmos is answering to these needs by several ways.
Во-первых, нами ведутся работы по завершению летных испытаний и принятию в эксплуатации модернизированной ракет-носителя «Союз-2».
Firstly, we are finalizing works for testing and commission of Soyuz-2 launch vehicle.
В рамках этого проекта мы установили более совершенную систему управления и новые двигатели на заслуженную и высоконадежную ракету «Союз», повысив ее грузоподъемность до 8350 килограмм на низкую орбиту с Байконура.
In the framework of this activity, we have installed new command system, a new command unit, new engines to the highly reliable Soyuz launch vehicle, and with these, now we can lift about 1.35 tons to the low orbit from Baikonur.
Кроме того, мы расширили номенклатуру головных обтекателей, призванных вместить космическую технику самых различных назначений и габаритов.
We also increased the range of payload variants, so now we can accommodate a wide range of payloads of different shapes and purposes to our rocket.
В результате теперь мы можем осуществлять как одиночные, так и кластерные запуски космических аппаратов на самые разнообразные орбиты с исключительно высокой точностью выведения.
So now we can perform both single or cluster launches to the very high range of orbits with high precision of orbit insertion.
So there's a very exciting field of development in your launch vehicles. Thank you very much. For a moment, please allow me to open the table again and to ask Mr. Bolden what do you see, what kind of status in the launch vehicle discussion concerning the NASA? And maybe I also may add a question from the auditorium. Do you see, Mr. Bolden, do you see the possibility of expanded international participation in the U.S. manned space exploration programs? Maybe these two questions fit together.
The questions fit together perfectly. As a matter of fact, for those of you who have been following the deliberations of the Augustine Committee on Human Spaceflight, if you read the summary report, there were several things that were very clear. One was that the need for enhanced international cooperation is vital. In my conversations with all of our international partners, with all of the heads of agency, I think we've all come to that agreement. The United States, I think you will find, will begin to focus on a heavy lift launch vehicle because our big impetus is going to be to get out of low Earth orbit and do the kinds of things that NASA was founded to do exploration, to visit other planets one of these days, to return to the moon perhaps, to look at some of the things that are out like asteroids and near-Earth objects. These are the things that are coming out of the Augustine Committee, and these are the types of issues that we will have to engage in our discussions with President Obama. I think if you look at what we're trying to do, our emphasis in terms of low Earth orbit access, right after Columbia accident, we would not have survived had it not been for the reliability of our partnership with the Russians. The Soyuz spacecraft, it allowed us to continue to operate on the International Space Station. We certainly will continue to utilize that. We are actually trying to do everything in our power to enable or to facilitate the success of commercial launch capability from the United States of cargo to low Earth orbit. All of us have talked a little bit about cost, and I would like to offer a caution. Everyone tends to think that we can change processes and get the cost down. My experience has been that gives you marginal advances or marginal benefits in terms of cost. What I think the importance of the international cooperation is that we have got to look at new technologies. We've got to look at, if you ask me about what the obstacles are to getting to Mars, we know their radiation and their propulsion systems. They're the ability of the human body to sustain long-duration spaceflight, and this partnership has been working on that for a number of years, all the way back to the Apollo-Soyuz joint test project in 1975. But it's propulsion that is going to be the key to, I think, to really getting the cost of routine access to space down, and that's something we're all going to have to work on cooperatively. Had a great time when I was in Russia 2 weeks ago talking with our partners at Roscosmos and Energia, and have talked about the same thing with the Japanese partners and others who are looking at new technologies, new ways of getting us out of the gravity well here on Earth and to low Earth orbit as well as beyond low Earth orbit.
Thank you. It's just a good sentence to come to the next question. In the following, it goes to Mr. Dordain. In the following decade, space exploration will face challenges as return to the moon or Mars, as you mentioned before. He has written a lot of students and young professionals in this ISC. What does agencies expect from the students and young professionals who will lead these challenges in the coming years? What are the main skills that will be needed and viewed to reach these objectives? Mr. Dordain.
Okay, just to say that first of all, the students will certainly do much more on exploration than I shall do myself. So, because we are speaking of the next 25, 30 years. So we are certainly expecting a lot from the students on exploration. Say that first of all, I would like to say that exploration will start by the success of the International Space Station. We shall not build the exploration on the failure of the International Space Station. And the International Space Station is already a success in terms of cooperation, in technology, in operations. It's not yet a success in terms of utilization. And this is where we have to demonstrate that we have to reap the benefits, and we have to demonstrate the benefits of using the space station. And certainly to make sure that the benefit to cost of the International Space Station will be interesting. We have first of all to see how we can increase the benefits of the space station, and on the other hand, decrease the cost of operations of the space station. And this is the starting point of exploration. Because increasing the benefits of the space station, it can start by, for example, increasing the partnership. We were speaking of India, we were speaking of other partners, and how can we open the partnership of the space station? Because clearly exploration will be a global endeavor, using all the partners which could join that global endeavor. It's number one. Another way to increase the benefits of the space station will certainly to work on transportation systems. I think that we have a problem of transportation for the up to 2020 and maybe even beyond on board the space station. And we have certainly to use the space station to prepare the transportation that we need for the exploration program. And this is where we have to talk together on what I have called a common transportation policy, where we can elaborate the common objectives, to have a review on what each partner can bring to these common objectives, and also, and this is certainly an important step, to have a standard interface. Because today we have not standard interface. Just to say that with the ATV we can only dock to a Russian system and not to a US system, and this is certainly a restriction. So we have still a lot to do on the International Space Station. And after that, we have to design the architecture of the exploration program. That architecture is not yet there. There is a lot of studies, there is a lot of ideas, but the architecture is not yet there because it should start by at political level. And this is where the conference that the European ministers will organize in Prague at the end of this month will be the start of a political process in Europe to design the exploration program. And what I hope is that this political process could be enlarged to all the other partners. And this is where I must say that we are just at the start of a process. And I shall finish by what I have started with. I think that the students will be much more part of that process than the ones who are today in front of you.
The work will not be finished when we meet again next year in Prague, so there's enough space for young professionals. The next question goes to Mr. MacLean. Mr. MacLean, what do you think should be the next large-scale international project after the ISS? It's easy to answer in one sentence.
Well, for me, Canada provided information for the Augustine Committee, and they asked exactly that question, and they phrased it a little bit different. They said, would you go to the moon first? Would you go to and establish a colony? Would you go to the moon and establish an outpost? And then would you go to Mars? And the answer that I gave at the time had to do with what it meant for Canada. If you go to the moon first as an established colony like the Antarctic Research Station, this is what it will mean. If you go to the moon as an outpost, at touch and go on your way to Mars, this is what it would mean for Canada. I guess your one line, or the simple way to say it, I would like to see us to have a destination of Mars and accomplish that before at least half of us on this row here, before we're dead. I think I thought I'd get more reaction than that. But Jean-Jacques was talking about the students, and the students will carry exploration, I'm sure. But I think it's possible for us to have a destination of Mars, and maybe we use the flex option, as it says in the Augustine Committee, where you'll test systems on asteroids or test systems at Lagrangian points before you actually head to that final destination of Mars. But I would like to see us actually set that as a goal and then figure out what's the best way to get there so that you ensure success in a relatively reasonable amount of time, so that most of us here in this room get to see that happen before the end of our day.
Thank you. I would like to give the last question to Mr. Joo-Jin. The question is for him, and it's written in very big letters. When will Korea go to moon?
Yeah, it's on my chart. It's such that we will send our orbiter in 2020, but still that program is only planned. But anyway, we have to make it in implementation. We need the budget from the government, so we just plan to send in 2020. under the condition of the budget.
So
Thanks.
we meet in 2020. I don't know where the ISC then will take place, but we will see then in 2020. Thank you very much for your answers and for your explanations, what we can expect during the next 12 months. I think there's more than enough to discuss in the workshops now. The theme of this Congress is Space for Sustainable Peace and Progress. And I remember the first words ever spoken in space by the Russian cosmonaut Yuri Gagarin. They were these: "I can see the Earth. It's so beautiful." My thanks to everyone on the podium again and to all of you for coming here today. Thank you for your attention and have a pleasant and inspiring afternoon. Thank you.